Okay, so today we're going to start with the net displacement of a particle. Okay, so your net displacement is really just the amount of distance you actually covered from where you started to where you finished. And even though distance and displacement is a different thing, just the distance in a straight line from where the particle started to where it stopped. Okay, so let's say if you had just a quick example. Let's say if you have a particle and it went like that. Okay, so let's say this is where it started. This is where it stopped. If you follow this path all the way around, then that will be your distance. But if you go from where you started to where you stop, that will be your displacement. Okay, so let's say we're going to go from some point S of A to some point S of B. Okay, so our S of t will equal our S of B minus our S of A on the interval from A to B. Straighten that up a little bit. All right, now if you remember, the integral and the derivative cancel each other out. The integral of, let's say, S prime of t is just S of t. You can do the plus if you want to, but not really worried about that on this one. Okay, so you have the integral and derivative just cancel each other out. This is just your original function. Okay, and if you remember, I'll draw a little box here. S of t, just your first function, no derivatives. That's your position function. Okay, your first derivative, S prime of t, remember, that's your velocity function. Your second derivative, which is the first derivative of your velocity function, which is your A of t, that's your acceleration function. Okay, so right now we're just going to look at this one. Okay, because this, if we replace our S of t with our integral of S prime of t, so our integral S prime of t, actually could have just, leave it like that, I'm on the right track, didn't skip anything, is equal to S of b minus S of a. Okay, now if we, let's say if we add S of a to both sides. Actually, we could just kind of add S of a, so you have S of b equals S of A plus the integral, and actually that should be from A to B. Kind of forgot that. The integral from A to B. And instead of S prime of t, we're just going to make that our velocity with respect to t. Okay. Now this is actually our, I guess you can call it our net change. Actually, make sure I got the right. Yep, that is your net displacement. Now when you have it in this form, I'll put it down here. The integral from A to B of v of t with respect to t is S of B minus S of A. That's your net change form. Oh, bring that up a little bit. Okay. Absolutely no difference other than that adding of S of A. Sure.
How is it that's trying to see how? Okay, so is it you added S of A to both sides, and that's how you got that, right?
Yeah, just added the S of A to both sides.
Okay.
So plus S of A plus S of A.
I just wanted. For some reason, I was thinking you added or you subtract S of B, and I'm like, how do you not get a negative?
Oh yeah, just be flipping it around once I added it. All right. All right, so let's say for our first example, if we're given that our velocity is equal to negative 2t squared minus 3t minus 3 represents the rate at which air is escaping from a balloon give the equation of the volume of air in the balloon after 6 minutes. After 6 minutes. Okay. Now they don't want us to solve it. They just want us to write out the equation. Now in the homework, they actually give you multiple choice options for this one. At least for some of them. Okay. So really we know that S of B is equal to S of A plus the integral from A to B of our velocity with respect to t. So in this particular one, we're looking for volume. So say since V equals the volume of the balloon, and your interval is actually from time equals 0 to time equals 6 minutes. t equals 0 to t equals 6. Okay. So really, this information here gave us all we need to know. Because we're going to replace the S with the uppercase V, that should be an uppercase V. And our B, well, this better yet is our A, and this is our B. So that means we're going to have V of 6 is equal to V of 0 plus the integral from 0 to 6 of negative 2t squared minus 3t minus 3 with respect to t. And that's it. All we needed was the equation for this one. So we're going to have somewhere we're actually going to solve it, but right now we're just rewriting it. All right. So any questions on this one?
So on that one, like you said, you don't find the integral out of that equation. You just plug in that equation.
You know, just for these, because some of them they just want you to find the actual equation and not solve it. All right. Okay, so for the next example, say if f of t equals negative 2t squared plus 5t minus 3 represents the rate at which a population is changing in thousands of people per year. Okay. Again, find the equation. That gives the size. Uh-oh, there we go. Of the population after 5 years. Of the population, that will be an uppercase P, after 5 years. Now, sometimes they will try to throw you off a little bit because this isn't v of t, it's just f of t. But you know it's the velocity function because they tell you it's the rate of change. So just the fact that they tell you it's the rate of change tells you that's what you need. That's your velocity function. They just chose to throw an f in there and kind of mess with you a little bit. Okay, so S of B, I guess you could say f if you wanted to, equals S of A plus the integral from A to B of your velocity function with respect to t. Or in this case, V of t equals f of t for this problem. Okay, so there is no law saying they have to use v, so if you see another variable up there, it's normal. Okay, so again, we know that we're going from t equals 0 to t equals 5. And our P is our population. Uh-oh. P-U-L-E. Okay, so instead of S of B, we're just going to make it P of 5 equals P of 0 plus the integral from 0 to 5. And instead of your f of t, we're just going to plug it right in. Negative 2t squared plus 5t minus 3 with respect to t. All right, so any questions on that one? All right.
So, real quick,
Mm-hmm.
if we were solving it,
Mm-hmm.
the P of 0 and P of 5, is that equation going to be the minus 2, minus 2t squared plus 5, or is it going to be the integral of that?
Actually, if you're looking for the net change, all you have to do is solve the integral. Because remember your net change, and actually I'll show you because it comes up on the next example. Oh, I'm still writing. Yeah. Keep that up for a few more seconds.
I mean, if it comes to the next example, it's fine.
Oh, okay.
I was just curious.
Oh, yep, it's the same thing. Because remember your S of B minus S of A is your net change, and that's equal to the integral. So really all you have to do is solve the integral, and you solve your net change. Okay.
Oh, and just the size of the population after 5 years is plugging in f of 5?
Yep, that's all it would have been.
Okay.
If you had to solve for it. Okay, but that's if you have your position function. And most of these are going to give you the velocity and not the position function. So if you have the position function, you could just have S of 5 minus S of 0. But since they're giving you the velocity, just find the integral of the velocity, same thing. Okay, so the velocity for a particle in motion is v of t equals t minus 15 meters per second. What is the net displacement of the particle from t equals 5 to t equals 9? Okay, so we're looking for really our S of B minus S of A, which is equal to the integral from A to B of V of t with respect to t. Okay, so this would be our net displacement. But since we don't have our position function, we have our velocity function. So instead of solving for these two, we just solve for this one. Give us the same answer. Okay, so we have the integral from A to B, so that's from 5 to 9, of our velocity function, which is t minus 15, with respect to t. Okay, so if we integrate this one, you have t squared over 2 minus 15t, and that's from 5 to 9. Okay, so if we plug in our 9, move that over a little bit, we have 9 squared over 2 minus 15 times 9 minus, now we plug in our 5 squared over 2 minus 15 times 5. Okay, which gives us 81 over 2 minus 135 minus 25 over 2 minus 75. And once you make that 135 over 1, make it 2 over 2, you get negative 189 over 2 minus negative 125 over 2, which gives you negative 32 meters. Okay. So it traveled negative 32 meters from t equals 5 seconds to 9 seconds. All right, so any questions on that one? Okay. Right. So let's say for our next example, have the velocity. Oops. Well, I guess you could say the velocity function, not a wave function. The velocity function corresponds to the motion of a particle measured in meters per second. Okay, so what is the net displacement of the particle for the first 5 seconds? Okay, and what if it's, our velocity is equal to negative 3t plus 2, and that was when t was between 0 and 2 seconds, and 2t minus 8, and that was when t was between 2 and 5 seconds. Okay, so we want to know the first 5 seconds. So we want to know from t equals 0 to t equals 5. Okay, so the integral 0 to 5 of v of t with respect to t is just going to equal, we have this interval from 0 to 2, so we have it from 0 to 2, and from 0 to 2 it's negative 3t plus 2 with respect to t, plus the integral from 2 to 5. And from 2 to 5, it's 2t minus 8 with respect to t. So you're just going to add them together. So really all they're saying is that for a short period of time, it was between 0 and 2 seconds, it was going a certain speed. Then from 2 to 5 seconds, it either picked up speed or slowed down, but it changed speed. Okay, so this is going to equal, if we go ahead and integrate this one, and actually let me move it over a little bit more so I don't run out of space. Okay, so you have -3. The integral of t is t squared over 2, plus the integral of 2 is 2 times t, and that's going from 0 to 2, plus, if we go ahead and integrate this one, that becomes 2 times t squared over 2, minus 8t, and I'll just go ahead and close the whole thing. And that's from 2 to 5. Oops, straighten that up. Okay, so that means now we have to plug in our 2. So we move that over just a little bit. If we wanted, we could bring the 2 out and have it -3 over 2. That's if you want to. You don't have to. But that would be, with the -3, I could have left that there. Okay, so you have -3 times 2 squared over 2 plus 2 times 2 minus, now we plug in our 0, -3 times 0 squared over 2 plus 2 times 0. Okay, so plus, if we plug in our 5 here, 2 times 5 squared over 2, kind of straighten that up a little bit. Minus 8 times 5, minus, now we plug in our 2, 2 times 2 squared over 2, minus 8 times 2. Just made it. Okay, so you have -3 times 4 over 2, which is 2. So that gives us -6 plus 4 minus, this just becomes 0 and that becomes 0, so that's just -0, which you don't have to put if you don't want to. Plus, these 2's cancel out, so that leaves you with 25 minus 8 times 5, which is 40. Minus, these 2's cancel out. So that leaves you with 4 minus 16. Okay, so we have, actually we don't really need parentheses. So we have -2 minus 0, which is just -2. Minus 25 minus 40 is minus 15. And 4 minus 16 is minus 12. And negative of that is plus 12. So you end up with -5. All right. So any questions on this one?